When you hear the words Big Bang, what do you picture? A blinding flash, a violent explosion, matter blasting outward into empty space. That image feels obvious, natural, almost unavoidable. But it's also wrong. Because the Big Bang was not an explosion. Nothing blew up. Nothing shattered into the void. In fact, there was no void at all. The Big Bang wasn't matter racing through space. It was space itself coming into existence, stretching, expanding, unfolding everywhere at once. There was no center, no edge, no outside. Every point in the universe was once compressed into an unimaginably hot, dense state, including the place where you're sitting right now. And misunderstanding this single idea doesn't just confuse the past. It distorts how we understand space, time, gravity, and the ultimate fate of the universe itself. So if the universe didn't explode into being, what actually happened? The explosion idea doesn't come from ignorance, it comes from experience. Every explosion we've ever seen follows the same rules. There's a center, there's a violent release of energy, and there's debris flying outward into surrounding space. Fireworks, volcanoes, bombs, even stars when they die. So when we hear the universe began, our brains instinctively reach for the only model we know, something blowing up inside something else. But the universe doesn't play by human-scale rules. Space is not a stage where events happen, it's part of the event itself. And this is where intuition fails us, because our minds evolved to understand falling rocks and burning fires, not reality at its most extreme. The moment we imagine a cosmic explosion, we're already thinking too small. To understand the Big Bang, we have to unlearn almost everything explosions have taught us. So if the Big Bang wasn't an explosion, what was it? The simplest answer is also the strangest. The Big Bang was space itself expanding, not matter rushing outward into emptiness, but the fabric of the universe stretching everywhere at once. Imagine every distance in the universe shrinking backward in time. Galaxies closer, atoms tighter, energy hotter. Keep rewinding far enough, and the entire observable universe collapses into a single extreme state. Not a point in space, but a moment in time. At the beginning, there was no where. There was only when. Every region of space you see today, every galaxy, every star, every atom, was once packed together in that early universe. And as time moved forward, space didn't explode. It unfolded. The Big Bang wasn't something that happened in the universe. It was something that happened to the universe. To make this idea easier to picture, scientists often use an analogy. Imagine the universe as the surface of a balloon. Place dots on that surface, each dot a galaxy. Now slowly inflate the balloon. As it expands, every dot moves away from every other dot. No dot is special. No dot is the center. From any dot's point of view, everything else is receding. This is what cosmic expansion looks like. But here's where the analogy breaks down. The balloon expands into surrounding space. The universe does not. There is no outer room, no higher dimension it's inflating into. Space itself is the thing expanding. The balloon helps us understand how distances increase, but not where the universe is going. Because the answer is unsettlingly simple. It isn't going anywhere. The universe isn't moving through space. Space is moving through time. If the universe didn't explode from a single point, then a natural question follows. Where did the Big Bang happen? The unsettling answer is everywhere. The Big Bang wasn't a location in space. It was a moment in time. Every region of the universe you can point to today was once part of that same hot, dense early state. The space between galaxies, the air around you, the atoms inside your body. If you could rewind the universe far enough, the place where you're sitting right now wouldn't travel toward some distant origin. It would simply become the origin. There was no special spot where everything began. No cosmic blast site, no central crater in the universe, just a universe that was once smaller, hotter, and denser everywhere, and then began to expand. The Big Bang didn't happen somewhere out there. It happened right here, and everywhere else at the same time. When we say the universe is expanding, it's easy to imagine galaxies flying outward, like fragments from an explosion. But that's not what's happening. On the largest scales, most galaxies are not speeding through space. They're relatively still. What's changing is the distance between them. Space itself is stretching. As space stretches, galaxies drift apart, even though they aren't actively moving away from a center. This leads to one of the strangest consequences in physics. Very distant galaxies appear to be receding faster than the speed of light. That sounds impossible, until you realize nothing is breaking the rules. Objects aren't outrunning light. The space between us and them is growing. Einstein's speed limit applies to motion through space, not to the expansion of space itself. The universe didn't fling galaxies outward. It quietly increased the distance between everything. In the early 1900s, the idea of an expanding universe sounded absurd. Most scientists believed the universe was static, unchanging, and eternal. Then Edwin Hubble made a quiet but revolutionary discovery. By studying distant galaxies, Hubble noticed that their light was stretched toward the red end of the spectrum. The farther away a galaxy was, the more its light was redshifted, meaning it was moving away from us faster. This wasn't random motion. It was a pattern. Distance and speed were linked. Every direction told the same story. The universe wasn't sitting still. It was expanding. And once that realization set in, the explosion idea collapsed. Because explosions slow down, their debris decelerates. But the universe was showing something different. A smooth, uniform expansion with no center in sight. Hubble didn't just discover that galaxies were moving. He discovered that space itself was growing. If the universe really began in a hot, dense state, then it shouldn't have gone completely dark. There should be leftover heat. A faint echo of the early universe still filling space today. And there is. In every direction we look, telescopes detect a soft, uniform glow. The cosmic microwave background. It isn't coming from a point. It isn't radiating outward from a center. It's everywhere. This light was released when the universe cooled enough for atoms to form for the first time, about 380,000 years after the Big Bang. Before that moment, the universe was a blinding plasma. After it, light could finally travel freely through space. What we see today is that ancient light stretched by billions of years of expansion. An afterglow from a universe that was once smaller, hotter, and denser, everywhere at once. An explosion leaves a center and fading debris. The Big Bang left a glow, uniform, ancient, and unavoidable. An explosion is a very specific kind of event. It has a center. It happens inside existing space, and it sends matter flying outward from a single location. The Big Bang matches none of those. If the universe exploded from a point, we would see a special direction in space, a cosmic center, a place where everything began. But we don't. No matter where we look, the universe looks the same. General relativity, the theory that describes gravity and space-time, doesn't model the Big Bang as matter moving through space. It models it as space itself changing shape. Distances grow because the geometry of the universe evolves over time, not because galaxies are being thrown outward like debris. When scientists try to describe the Big Bang as an explosion, the equations stop working. When they describe it as expansion, the math holds together and matches observation. The Big Bang wasn't a violent blast. It was a transformation of reality itself. Understanding the Big Bang as expansion, not explosion, does more than correct a mental image. It reshapes how we think about reality itself. If space can stretch, then time can stretch too. Gravity can bend. The very structure of the universe becomes dynamic. This insight led to some of the most profound discoveries in cosmology. Inflation. the universe expanding faster than light in its earliest moments. Dark energy, the mysterious force accelerating expansion today. The realization that the cosmos doesn't revolve around us and that its future is still unfolding. The Big Bang is not just a beginning. It's the framework that explains how everything moves, how galaxies drift apart, and how the universe evolves. And it shows us that our everyday intuition can't always grasp the vastness of reality. The universe isn't a stage for matter to move across. It's a fabric that grows, bends, and shapes the destiny of everything inside it. Even after we understand that the Big Bang wasn't an explosion, people still have questions. What was before the Big Bang? Is the universe finite or infinite? Is the expansion slowing down or accelerating? The truth is, we don't fully know. Before the Big Bang might not even make sense. Time itself began with the Big Bang. The universe could be infinite, or it could be a closed loop we can't yet fully grasp. And the expansion? It's not only continuing, it's accelerating, driven by something mysterious called dark energy. These questions remind us why it matters to get the Big Bang right. If we imagine it as a simple explosion, we can't even ask the right questions. We'd never glimpse the deeper, stranger truths about reality. The universe doesn't fit our everyday logic, and that's exactly why understanding it properly is so important. So why does it matter that the Big Bang wasn't an explosion? Because it changes everything we thought we knew about the universe and our place in it. The Big Bang wasn't destruction, it was creation without a center. A universe that has no privileged location, no here more special than there. Every point in space shares the same history. Every atom in your body was once part of the hot, dense early universe. And maybe the most humbling part? The universe is still unfolding, space is still stretching, time is still flowing, and the cosmos will keep evolving long after we're gone. Understanding the Big Bang as expansion, not explosion, isn't just about physics. It's about perspective. It's about seeing the universe for what it really is, vast, strange, and infinitely beautiful. The universe didn't explode into existence. It unfolded.